Hey, hello, my name is Muhammad Amir bin Aziz, ID 180000848. Today I will present about the lab assignment 2, which is Bernoulli theorem. So here is some picture of the Bernoulli equation. So, okay, for the introduction, so what is Bernoulli equation? Bernoulli equation consists of three terms. The first is P plus half rho V square plus rho GH. So the first term is referred to the pressure energy, and the second term is referred to the kinetic energy per unit volume, and the last term is referred to the potential energy per unit volume. So the V is velocity of the fluid, and the H is the elevation of the fluid. So to use this equation, there are few conditions needs to be considered. The first is the fluid viscosity is negligible, and the second is flow must be a steady flow, and the last one is motion is only involve pressure and gravity force. Okay, here is the objective and the methodology. For the objective, this test is to examine the validity of the Bernoulli equation when it is applied to a consistent flow of water through a Titan pipe. And in this experiment, the validity of the Bernoulli equation will be checked with the utilization of the Titan pipe, which is venturi system, and associated with the manometer to measure the pressure head at a certain point along the stream. Okay, here is the setup of the experiment. We have water inlet, adjustable feed, test section, hypodermic probe, gland nut, unions, manometer tube, and air bleed valve. So the pressure will be measured by the manometer tube along the section, test section. So for the test section, we will make a 6 hole to measure the pressure. First is H1 and H6 is the at the before the Titan pipe. And next the 4 more is within the section test where we have a Titan pipe. The smaller we will decrease the area. Okay, here is the result of the experiment. So as you can see, the lowest diameter is D, which is the smallest area. So the velocity will be the highest. Among all the points, D will be the highest velocity, have the highest velocity. So it proved that the Bernoulli equation. Okay, here is the discussion. After we plot all the data obtained from the experiment, it shows there is decreasing in the height of manometer when there is decreasing in the area. It shows that the area is directly proportional to the pressure. So when the area is decreased, the pressure will also decrease. But the theoretical and experimental value is different at the last point, maybe caused by the friction of the tube. So this type of information is very useful in the case of nozzle, diffuser, and jets. Okay, for the conclusion, from the result obtained, we can conclude that the Bernoulli equation is valid, as when the area in the Titan pipe decreases, the velocity of the fluid will be increased and the pressure is decreased. So all in all, area is directly proportional to the pressure and inversely proportional to the velocity. So the picture will be the summarization of this Bernoulli equation theorem. Thank you. That's all from me.